For question number 5, we have to verify that two functions are inverses, and we do that with composition. So remember, in order for them to be inverses, that would mean that when you take your g function and put it in the f function, it would come out and simplify down to just x. And if you take your f function and put it into your g function, it would also simplify down to just x. And when you're doing this, you only have to show that one is true. So for the purpose of this, I am going to do both so you can see how they would both work. So let's start off with my f function, which says the square root of 3 times something minus 2. So the something is g of x. And when I put this in side of the parentheses, the first thing that's going to eliminate, there's a couple different ways, but I'm going to start by multiplying the 3 and the 1/3, which is going to break down to just x squared plus 2 minus 2. And then my 2's will cancel out. So I'll have just the square root of x squared. And that's just simplifying down to an x. And again, what does an inverse mean? It means that your domain in one function is your range in the other. So the x and y variables reverse. All right, let's do our second composition. So if you were to pick the g of f, which can also be written as an open circle. So if I take my f function and put it into my g function says 1/3 of something squared plus 2. And the something is f of x, which is going to be the square root the square root of 3x minus 2. Well, the first thing that's going to cancel is the square and the square root. So that's going to leave me with 1/3 times, and then I would have 3x minus 2. The second thing that would cancel out are my 2's. So then that would leave me with 1/3 times 3x, which is the same as just saying x. So again, you can see how they would both work. So now let's practice finding the inverses, and then we're going to state the domain of the inverse that we come up with. Remember, f of x is the same as y. I'm going to switch my x and y and simply solve for y. Again, at any time, I do recommend that you attempt to do these problems on your own and then come back to the video. You can pause it at any time. I'm subtracting 3, and I'm taking the square root. So my inverse function is the square root of x minus 3. And the domain, because x minus 3 has to be greater than or equal to 0, that means x is greater than or equal to 3. So that would be bracket 3 to infinity. So this would be my function, my inverse function, and this would represent my domain. All right, let's look at question B. For question B, I have y equals 3x minus 7. I don't have any red lights or exponents, so that's a pretty good sign for my domain. X equals 3y minus 7. I'm going to add the 7 and divide by 3. And that is how I get my inverse. And there aren't any red lights, so my domain is all real numbers. So this is my inverse function. And this is my domain for part B. All right, let's look at part C. I have y equals x plus 2 over 5. X equals y plus 2 over 5. I'm going to multiply both sides by 5. And that cancels out my denominator. It leaves me with 5x equals y plus 2. Subtract the 2, and my inverse function is 5x minus 2. And my domain, again, there aren't any red lights, is all real numbers. So let's talk about graphing exponentials. So the one good thing is that all exponentials have a domain. They all have the same domain, and that's all real numbers. If this number here is greater than 1, it is going to increase. And it's increasing across the domain. So whatever your domain is, that's your interval of increase or decrease. So I'm going to go ahead and create a table here. I'm going to make one with my base. So I have y equals 2 to the power of x. And actually, let me move this over just a little bit. So I'm going to make my table. And I'm just using -1, 0, 1, 2, and 3. A base of 2 is the only one that I can go up to 3, but because we're talking about exponential and it's repeated multiplication, you generally can't have that many points because our grid is just a 10 by 10. But in this example, we can go up to 3 because 2 to the third is still less than 10. So anything to the power of negative to a negative power is going to be the reciprocal. So the reciprocal of 2 is 1/2. This is 1. I'm just multiplying by 2 all the way down. You're multiplying by your base. I feel like I should move that up a little bit because that looked like a 7. All right, so a couple of things. First thing is going back, this K value is your horizontal asymptote. So that's going to be at y equals -1. I'm going to go ahead and draw that on my graph. So this graph is not going to touch or go under this line. We can see our y-intercept because the definition of y-intercept is your y value when x is 0. Well, let's look at what we got when we put in a 0 for x. Well, actually, this is my parent table, so we can't do that. All right, so going backwards, sorry. All right, so now let's go ahead and do our transformations. Okay, so looking at our original function here, our a, h, and k value. The a value is the number in front of 2, which is just 1. The h value, you always flip the sign, that's -3. And your k is -1. Okay, so you always, it's always x plus h, y times a plus k. So what I'm going to do with all of these numbers, I'm going to add h, which is -3. So I want you to add -3 going all the way down. And then you're going to take your y values. You're multiplying them by 1, which does not change it, so I'm not going to write that. And we're also going to add k. So I'm adding -1, which is also the same as just subtracting 1. So I'm going to make my second table. This is the table that I'm going to graph. So this is what I get after I do my transformations. So this would be a -4, a -3, a -2, a -1, and a 0. 1/2 minus 1 is a -1/2. 1 minus 1 is 0. 2 minus 1 is 1. 4 minus 1 is 3. And 8 minus 1 is 7. Okay, so now looking for my y-intercept. The y-intercept is the y value when x is 7. And if we look at our transform table, that occurs right here. So that would be my y-intercept. And my range is k to infinity because it's increasing. So my k value is -1. So it would be -1 to infinity. I'm going to go ahead and graph my table here. So I have my y-intercept is here. At 4, we're here. At -2, I'm up 1. At -1, I'm up 3. And at 0, I'm at 7. And when I cross through it, it just looks like a backwards L. It goes straight out. And that is the graph of your exponential function. Zoom out so you can see the entire problem. Let's look at question number 8. For question number 8, this is a decay graph. This is decay. So this is a decreasing graph. And it's going to decrease across my domain. So that's going to be -infinity to infinity. There is an invisible +0 out here. So that's k. So my range is going to be 0 to infinity. My horizontal asymptote is y equals 0. So there aren't any transformations. So there's a couple different ways to do it. I think the easiest way, though, is to just use our exponents. Now, because it's decay graph, it's a decay graph, I want to put more of these numbers. So normally I would do -1, 0, 1, 2, 3. But now I'm going to do the other one. I'm going to do 1, 0, -1, -2, -3. Because it's a decreasing graph, I actually need more points over here. So when I create my table, I am going to have +1, 0, -1, -2, and -3. Let me move that over so I could try to fit it. Okay, let me move it over here. So I have 1, 0, -1, -2, and -3. If you were to type this in your calculator, you would get 1/2 to the power of anything to the power of 1 is going to be itself. I'm going to actually write it as a decimal. And any term to the power of 0 is 1. So 1/2 to the power of -1 is 2. 1/2 to the power of -2 is 4. And 1/2 to the power of -3 is 8. So when I graph my function here, and before I move forward, we can also see my y-intercept is right here. So I'm going to actually transfer that over here. All right, so now that I have all that information filled in, I'm going to go ahead and create my graph. So I have a point at 0, 1. At -1, I'm up 2. At -2, I'm up 4. At -3, I'm up 8. So it's going to come down, hit that last point, and then it's just going to go straight out. So if you trace this graph from the left to the right, you see it's decreasing. You always read a graph from left to right.